What is cancer? Before we start talking about what is cancer in details and the different types of cancers, we need first to talk about what is cancer. Now, cancer, you might have heard, is of course a condition that is very devastating, but it starts at the cellular level. If we want to understand what is cancer, we need to understand that it started at a cell. Now, I don't want to take you to high school biology, but if you remember, all living organisms, they have one or more cells. Now, think of amoeba, for example. Amoeba living in the pond, it's just a simple, cell which has everything around its surroundings. When it comes to multicellular organisms like a human, we have so many cells that have to work together in harmony to be able to, keep us alive. So all the cell, we have so many cells, and each cell have, of course, its surrounding membrane that keeps the certain parts of the cell inside, including the DNA, which is basically one of the key things of the cell. Of course, the other part of the cell that I'm not going to bore you with that. But generally speaking, so the cell, it's amoeba, for example, unicellular cell, it lives just around the pond. It gets oxygen, nutrients just from in the surroundings, and it excretes its what's a product into surroundings. But human cell, think of the kidney, for example. The kidney is not outside the cell it's not outside towards to the environment whereby it can get oxygen. It needs to work together with other cells to be able to transport oxygen and nutrients into that kidney. So we have about 37.2 trillion cells in our body. But when you think about all these cells, we did not start with that cells. In fact, we started just at when the sperm met the egg after fertilization, it was just one cell. In fact, about 12 hours after fertilization, really nothing really happens. But 30 hours after fertilization, and then what happened is you have that fertilized egg that started becoming, 2, and then 4, and then 16, and then multiplication just continues, and that's how basically the cell replicates. Now, this is very important. The cell division. Without a cell division, of course, we wouldn't have babies. And even if we happen to have a human beings around, we wouldn't live that longer. So cell division is a key for the all living organisms, including the human of course. In fact, with our cell division, think of, for example, we shed about 40,000 cells every single minute of our skin. Now, without cell division, then we'll be run out of cells. But thankfully, there is cell division that takes place to be able to get that. Now, these cells, though, you have a certain specialized cells. When they work together in harmony, then we put those tissues. When cells working the same function to come together, they call tissues. And tissues coming together, then they form what we call an organ. Think of the heart, for example. And then the organs are coming together, working in harmony, working in carrying certain function. Then it's a system. So the organism, the human organism, is made of all these different systems to be able to carry out all the function. Think of the cells as small factories that exist inside in our bodies. All these factories working together for the optimal working function of the whole system. Now, like I just mentioned, cell division is a key for even to take place. So cell division is very important in order for the bodies to grow and develop. Of course, it allows the death of old cells to be carried out, and also it helps to repair the injuries of the cell that already have injured. But this, importantly, this cell division, it happens in a very strict way. With certain stages and checkpoints to make sure this is the cell division, the cycle happens without mistakes. Because if there are mistakes, that's where we might start having a problem. Now, the cell cycle basically it has two stage. There's interface, which is including what we call G0, G1. That's gap 0, gap 1, gap 2, gap S, and gap 2. S is basically DNA synthesis. And then there's mitotic part of it. Now, during the interphase, which is the first part of the cell cycle, that is where the cell grow and they replicate, DNA replicates. In the second part of the cell cycle, the replicated DNA now and other part of the organism, they organize themselves, they separate, and they actually make it the daughter cell, so to speak. Now, these checkpoints are very, very important. From gap 1 to DNA synthesis to gap 2, there is checkpoints to make sure the cells that are sick get repaired. Those that are old and dead get taken away. Because if there's any mistake that is carried out that can end up going through the mitotic stage, then that may be problematic, as we see. So, so what is a cancer then? Cancer then is basically the cells that have gone wrong. The cells that are no longer respecting those checkpoints that we saw in the cell cycle. And then not only that, they started growing abnormally. And sometimes they start growing even fast. In the later stage of cancer, cells break through normal tissues boundaries, and that's so-called metastasis. And this is spread to other part of the body. So, in a nutshell, cancer is basically the cells that are behaving abnormally. They started creating sometimes. And the cell that basically have gone wrong. They started sometimes becoming abnormal, creating their own blood supply and then they started multiplying non-stop. Now, that's the key. We need to understand what cell is. It's basically these cells, when they're no longer respecting these checkpoints, that they may be cancerous or they may become other diseases that are problematic. Now, there are different types of cancers. There are some that have been clearly identified, and there's some that haven't fully identified. We're going to be going through those that have been identified, and we'll talk about what can we do to prevent these cells becoming abnormal. And if you have a cancer already, what can actually be doing to be able to prevent the progression of this cancer. And that will be next. Thank you so much for watching. See you.